Hi everyone, in this video we're going to build an object detector on Tensorflow, React.js, and on the browser. As you see here, it's actually that we're going to be building throughout this video, just an object detector where it allows you to select an image. Once the image is in there, it's just going to detect whatever type of objects it supports, obviously, has been trained on to detect on that particular image. And we are going to just display all these bounding boxes by ourselves. We're going to create it ourselves. We're going to just display, the type of the objects or the class, a cat or dog or whatever, and it's all going to happen there. And even here, clearly see you can select it, and you can select, for example, people crossing the street or whatever. Yeah, it takes quite some time to do so because it's our browser and it depends on the image, but eventually it does it. It just go ahead and says which type of persons. It's not 100% accurate, has none of AI or machine learning stuff but it needs more training, obviously, but it does a pretty good job depending on that. And it's on the browser with just TensorFlow and COCO-SSD model, and it's doing it great. So you got a lot of opportunities to go in and test that out. And I'm going to build it from scratch on this video using especially React.js, TensorFlow, COCO-SSD as I said before, and all the stuff that we need in here into this video. So yeah, without further ado guys, let's go into it. So let's just get started, and here actually we've got a blank page. I've used React Create App as always. So for any React projects we set up, we use React Create App, okay? And what we're going to be using in here is actually the most important part is Tensorflow.js with the COCO-SSD model, and it is actually the object detection model that we're going to be using throughout this video tutorial to detect different objects on images, on just static images. Just give them whatever image and it tries its best to detect whatever objects within the image, like cats, dogs, cars, motorcycles, whatever. So it just tries to do that. And this COCO-SSD actually has been trained really well, has a huge data set has been trained with. And you can check out here more information about how it has been trained from the cocodataset.org. It has the full website, and it actually supports 80 classes of objects, which is pretty great. So you can have bicycles, persons, cars, motorcycles, trains, yada yada yada, elephants, bears, zebra, skies, many more, like chair, TV, oven, and teddy bear. You got a lot of classes too. It's in 80 classes. I think it's 90 as I've seen it right now. Probably 90. Let me I see 90 in here. Probably the README hasn't been updated. So yeah, we got 90 and it always being expanding over time. So that's pretty great. And the most important part is you can use it from a canvas or from a video stream. So you can do real-time object detection on a video, but that could be taking quite some time and it won't be really precise. So I will go for images because it's easier to set up, easier to work with, and it can demonstrate things really well. Here's actually how to set up. It actually has a pretty straightforward instructions in here, how you use it, but I haven't got so much luck with it. So I tried to actually set it up with these instructions and it failed a little bit. I got some issues, but overall I will show you how to go ahead and set up, install dependencies, work on the projects, and get started from scratch. And without forgetting, if you are interested into this TensorFlow or TFS.js models, it has a pre-trained models ready-made for TensorFlow JavaScript, and I mean JavaScript because it runs on the browser and maybe on Node if it is supported. And it has a pretty awesome models on here, pre-trained, and you can just get started and use them out of the box. So COCO-SSD is one of them, and that's why I got it in this video tutorial. So yeah, interesting, and let's jump right into it. So let's just go back in here and let's start by just setting up things right here. So if you're not familiar with how to use Create React App, if you're a beginner, this is how you do it. So you're gonna use npx. Always try to use npx and make sure npm is installed alongside Node, and just do npx create react app, and now provide whatever name you want to name your project, like my object detection or whatever. Click enter, and it's gonna do the magic. It's gonna start setting up using npm to install dependencies, grab create react app, and so on and so forth. So this is going to take quite some time to do. They install all the dependencies. After it does, open your VS Code, or whatever code editor you prefer, and let's jump right into it. So I already did all of that steps here. I got the upper running, it's running, have like object detection, it adds some a little bit of things in here. And what dependencies I needed to install, actually a couple of easy ones. Now, these are actually the problems that I've set up or I've like encountered throughout the setup, and when I try to install the dependencies, I just encounter some issues, like sometimes it doesn't meet pure dependencies, sometimes it doesn't like found a module, even though I'm installing it, but it doesn't find it. So yeah, it's quite a huge issues. Now, what I advise you to go through if you want to set up this project is actually to go ahead after like setting up the Create React app, open up the pack.json and just go ahead and manually add the modules you're going to be using, then remove the node modules, then run yarn or npm install again, and it's going to like install everything from scratch, so no issues will be caused by this option. Now here actually what we're going to be needing, actually make sure to add pure dependencies, and this is what we need as pure dependencies. So TensorFlow, backend CPU, backend WebGL, Tensorflow.js converter, and the core of TensorFlow. So whatever version you are actually having there, you can, for example, run yarn and TensorFlow backend CPU to see just the version. Then you can just like remove Node.js, but I don't really recommend that. So just copy these, or just like go and search them, Google, find them, put them right here, and also go top to the dependencies section and do the same. Just copy paste all of those and put them right there. And make sure to install as well the TensorFlow COCO-SSD. So TensorFlow models COCO-SSD, and this one is actually the portal or the API I'm going to be using to access the TensorFlow core and the backend CPU and make them all work together, you know, to just like do image detection or object detection inside of images. Okay, so yeah, this is exactly what I'm going to be using right here. Make sure to do it that way. Add it all into the back.json. Afterwards, go ahead and like remove the node modules, completely get rid of it, and we run yarn. So just like run yarn, it's going to use the package.json, whatever is there, it's going to install all the dependencies, or you can pretty much just run, where is that? So npm install, boom, and everything would be running absolutely perfect. So yeah, this is pretty much what you need to do. This is pretty much what you need to install to get started. One more things we needed is actually to install. So after doing all of that installing, you can go ahead and safely install styled components. So the reason I'm just going to use style components, just I'm going to put some object detection. So we want some boxes to do custom CSS and custom components. And since style components are our friend, we all love it, and it makes really well like a good relationship with React. So that's why I'm going to be using that case to do custom components and just like hook up CSS into it. Pretty great. So let's just jump right into it. This is all the setup you need to do. This is everything that you need to be installing throughout this, and you've got your React application already running. So just go ahead and run yarn start. So just do yarn start enter, and it's gonna like start up. I already did like start up the server here, the development server, and we are good to go. So if we now jump back, we got the object detection and it's running, and this is the COCO-SSD. So maybe we can like go ahead and use some, I will just like walk you through here if you like go through, just to show you exactly what I'm talking about and how the API works. Okay. So yeah, nonetheless, we can go ahead and just get started. And here for the object detection, I already got some like sample images we're going to be working with. So for example, a lot of cars, cat images, crossing the streets, like images of people, me and my dog, whatever. So we're going to just choose a couple of these images to test with after we finish building it. Okay. So yeah, nonetheless, it's going to start. I'm going to put a components folder in here. As you know me, if you watch my other videos, I always put in things like components and try to structure it as much as possible so everyone can understand what I'm doing. And just like if he wants pretty much to take this project, or just like take the knowledge, take the component, just the single components from my projects and port it into your project, it will be easy. It won't cause any conflict or something. Okay, so that's why I put it that way, if you are ever wondering. Okay, here I'm gonna have components. Inside of components, we're gonna just like create object detector. So this component is gonna do all the object detection and everything. I'm gonna just put it inside of that component. So I'm gonna have it index.jsx as always, and we can get started. So let's go ahead and import React as first things first, as we all love React. I'm gonna export a normal functional components. So it's gonna be objects detector. It's gonna have props and pretty basic stuff, nothing too complicated. So what I'm going to start with, I'm just going to put the layout first. And if you like seeing the layouts, like from my introduction, what we built finally, so you can see like we've got a preview image, like what is the image being processed in the middle. Then we got just like a button right beneath it where we can select a new image and start like detecting whatever object. So as soon as it's being selected, as soon as we pick up an image, it's just going to automatically start like, start the algorithm and start detecting whatever objects inside of that image and just like renders bounding boxes whenever it finds these protections. Okay, so this is exactly what we're going to be start doing. This is actually the layout we're going to put together first before jumping to the logic and putting together pretty much the object detector and using TensorFlow and COCO-SSD. So how I'm going to create the object detector container. So I'm going to use style components, so just like auto import with VS Code awesome feature. And here I'm going to have display flex, the flex direction as a column as always, and I'm going to have like align items to be on the center. Okay, just like to align centering the items right there and to make them look really, really perfect. Now here we're going to have, actually this is the main container where you can hold the like the container, the image container, and you can hold the button where we can pick up an image, right? So beneath it, I'm going to have like the container where it holds the image. So this is actually going to call a detector container where the image is going to like live in. It's going to be style.div. Okay, so I'm going to have, let's say a minimum width of 200 pixels, height, let's say 500 pixels, maybe more or less. We will see as soon as we do. I'm going to have like a border of 3 pixels, solid, and FFF, so I'm going to have like complete white for this. Border radius, I'm going to have like 5 pixels of border radius probably, and I'm going to have display flex, so flex direction, or just like align items to be centered, so to center everything into the middle, whether horizontally or vertically, it would look fine. And last but not least, we're going to have position relative, and that's because later on we're going to have some absolute positioning going on with the bounding boxes and everything. So this one is going to help a lot, putting it into perspective and just like, center it inside of the image. We will talk more about that later on once we reach the object detection section. So here we got the detector container. Everything is working absolutely fine. Now here I'm going to create another element which is going to represent our target image, which is the image we're doing the processing on or whatever things. So targets img, so style img, and for this one I'm just going to have height take 100%, and for the width is actually going to automatically fill in. So this is actually a quick trick about how you auto detect and put images on the same aspect ratio without like playing around and cropping it the wrong way. Okay, so always on CSS, if you want to keep and preserve the images aspect ratio and just like resize it on your own size, make sure to only resize and put a custom height and put the width to be auto. Here the width is actually auto. I'm just like specifying the minimum width, and for the image I'm making it take the full 100%, which means taking 500 pixels. But for the width, I'm just like leaving it auto by default. You can just put width auto, just like completely ignore it as I'm doing here, and it's just like gonna preserve the aspect ratio, which is pretty great for images to be able to render them in the natural way, just like not really a foggy or fussy way. You don't want that, okay? So yeah, we got it right here. Next we want is actually an input, right? Because what we want is actually to I've been able to click a button, then trigger some click events on an input, the file input, then open up the file picker from your browser, your native file picker, as you do, file uploads, pretty much. So here I'm going to have like a hidden, hidden, whatever. So I'm going to have like hidden file input, and it's going to be a style.input, right? And the reason I'm naming it hidden in here, because it's going to be completely hidden, because I'm going to have like display none. I'm not going to show that wherever, and I'm just going to like use it as a placeholder. So later on, whenever you click on it, it trigger that event and it start working immediately. You will see what I'm talking about in a second. The next one is actually we're going to be needing a select button So I'm actually gonna style this select button a little bit, and I don't want to just go through all the complexities and stuff like that. I'm just gonna copy the code, okay? So because it's not really important to have a button in here, I'm gonna have artifacts, got cursor, transition, just basic CSS stuff. So I'm just gonna like quickly go through that. I'm not really gonna go through deeper into this. And last but not least in here, we got some target box, but I'm not gonna be talking about it yet. So let's go ahead and jump and to start into putting some logic into our object detector. So before getting started anywhere sooner here, so we have to import 3 important modules. So the modules we have installed before, the TensorFlow modules, we have to import them first on the top right here in order to be able to work with them on for the object detection actually. So we're gonna just go and import the TensorFlow, the CPU, and the TensorFlow, the WebGL. Now, quick notice about this, as I've read a lot of documentation and just like read through a lot of GitHub issues and stuff. So this WebGL is actually optional. You can just like leave it fall back into the CPU, or you can just combine them together. As I've read, probably using or sometimes just like discarding and not using the WebGL make it a little bit more performant. I don't know. I haven't found a lot of differences, but we will see throughout the videos how it goes on and on. Okay. And last but not least, make sure to do imports all as COCO-SSD from the TensorFlow COCO-SSD. And that's pretty much all you need, and everything is going to like magically import on itself later on as we go like through it and exactly know how to work with that as we move around. Okay, so yeah, pretty basic stuff, pretty easy, nothing too complicated. Now let's go and render stuff first. I'm gonna have here like the objects detector container. We're gonna have objects detector, and for this one we're gonna have like an image, right? So this is where the image is gonna live in. We're not gonna have any src. I'm just gonna like put an img here, just like this placeholder for it. The other one is actually, I think we named it select button. Yeah, exactly. So select image, and this is what is going to be used for just like selecting an image and yada yada yada. So this is basically what we're going to have it. Instead of it is going to be the image and how we go. So let's go and render out this. I think we got enough data just to get started and render what we need. So objects detector. Okay, fair enough. Compiling, pretty great. So I'm not sure refreshing this will work or not. So object, and we got, okay, that's pretty bad. Yeah, it has been stopping already because I was calling this in a loop, and that's quite crazy. So let's get rid of this one. I have a local, okay, that's messed up. Localhost 3000, and there you go. So we got an image inside of it. This is where we want to render up the image, and now you see like the width is really small, but we have it autos, which means once we select an image, it's gonna like autofill. And this is actually the select. But now, right now, once you click on it, it doesn't do anything. Now, what we want is actually to click on this. We are gonna trigger the file input that we hide, and just like it's gonna just trigger up a file picker window for us. So this is where we want it. I'm gonna just like render the hidden file picker, and make sure to put the type as file, otherwise it won't work, and that should do the job perfectly right here. As clear as see, it's gonna be hidden, not gonna see in it, but still we're not gonna do anything on it yet. So let's go ahead and do right now what we want is actually to, once we click on it, we're going to trigger the inputs or the on click on that particular input, right? So we want to select an image, then we want to like read whatever is actually from that image, right? So that's basically what we're going to have like right now for like selecting an image and how it works. So I'm going to have in like a function in here. It's called open file. And all it's gonna do, it just like opens the file picker, right? And in order to be able to like trigger and click a custom and a manual events on this input, we have to hold the reference for it. So we're gonna just like do file input ref. I'm gonna use ref. This is actually a really awesome hook. It's gonna allow us to do so. And here we're just gonna simply pass in the ref prop, and it's knowing exactly what we want. So now what we want is actually to check if the file input ref.current is not null, so it is completely valid objects. If so, what we're gonna do, that's current, and trigger the click on it. And last but not least, we have to pass in the onClick to open file picker into this, and that should do the job right now. So if you go, if you click, boom, we got that. We got this file picker picking up like all of this in a really awesome way. So yeah, stuff going on pretty awesomely. And yeah, so we got the file picker right now. Now what we want is actually whenever we select a file, we need to load the image and display it under here. So this is going to be like quite a bit of complicated thing, because we're going to have like to go ahead and use the file reader and read from the file and so on and so forth. So this one is going to take quite some heavy liftings. So we're going to have a function here. So it's going to name it on select image. So this one is probably gonna like take an event, because we got an event and I want it to be asynchronous, to use async awaits on this. And for this one, we're gonna be passing it right into here. So I'm gonna do the on change. So whenever it changes, like whenever a file input changes, what we're gonna trigger is on select image, right? And it's gonna pass in the events and everything that we want it to be. Now we're gonna have like to access the file. In order to be able to access the file, we have to do to access the events.targets.files. So there's a files array there, and it's gonna hold a single file because we're only gonna allow it to choose a single file, not a multiple files. So here, make sure to choose and select the first one, the first index, which means it's the first file, and it's gonna do the job for us. Now, what I want next is actually to have another function that allows us to read this image. So we read the image from the disk, allow the browser to read it, process it, and just like return the image data in a base64 encoded. If you're not familiar with base64 encoded, it's just like encoding binary data into more like a string format data that we can understand as a human, not binary that cannot be represented pretty much. So you can think of it like a blob converted into a string. That's basically what it is. And it's more like an encoding, right? So it encodes these binaries into that string. Whatever. So here we're gonna do like read image, and this one I'm gonna just like pass in a file, and it's gonna like have a promise, which means it's gonna return a promise. We're not having it there, so it's gonna return a new promise. So we're gonna have resolve and rejects for that promise, and we're gonna use the file reader. So the file reader API is actually available on pretty much any browser version, any type of browser, and also to read from the disk whatever files and just like load them in either blob, like binary, raw binary data, or base64. So that's what I'm going to be doing right here. I'm going to have like the file reader to start reading for, so I'm going to initialize a new file reader. So creating an instance of file reader, then we just like do file reader.onload, and this is a callback called whenever the file and the image is completely read and like has been processed and it's ready to like continue processing with it. So when you finish loading, this callback is going to be called, and what I want to do is actually call a resolve with the data. So the data to access just side of the file reader and dot results, and this is where you access the data. Next, you got the file reader on error. So if any errors happen, we want to reject real quick. So just like file reader dot error, pretty simple. And last but not least, make sure to do like file reader dot read as data URL, and this one is going to just like read it as a base64, and make sure to do it that way, otherwise it won't work for you, and you have to do like more conversion and more like converting the data between binary, base64, so on and so forth. So here we got everything working fine, and this one is gonna like resolve the image whenever pretty much we got the image, is gonna resolve us the promise with that data. So here we're gonna have like image data equals await read image, and all we need to do is just pass in the file that we got as Kaddish. So everything would be working on that particular scenario here in the right way. So pretty cool. Now we got the image data. Now all we simply need to do is just go ahead and like hold up a state on the top right here. I'm just gonna have it beneath this one. So it's going to be called image data. So it's image data. So use state, and it's going to be null as first. So we can render up an image. So we can have it like an image here. So the src is going to be the image data. So you can pass in directly a base64 string into the src and the browser would read it. So this is actually a really powerful feature of how JavaScript works in general. So we got make sure it is valid. So image data is valid, and so we can't render null if that would cause an error. So we'll want to do that. So here, last but not least, make sure whenever it loads, make sure to do set image data to be the image data that we want, and that would make it load everything as we want it to be. So let's go and try it out. I guess this will work perfectly. Okay, failed to execute arguments required, but only 0 is present. Yeah, here we have to pass in the file, but ironically we haven't. So try to do that again. Open up. That's I guess another issue. Read data, file arguments, but whatever. Maybe I need to reload. There you go. Yeah, we needed to reload very badly. But yeah, nonetheless, it works right now. And I guess a 500 pixels isn't really enough for the height. So we can go ahead and try to do the 700. I think this one is okay. I'm not sure about this. Okay, we don't have the target image. We used image elements. Yeah, that's pretty bad. Now we got it doing it the right way. So it's putting the image, even though the image is really not that high resolution. So it's like using its full potential, I guess. So you can have it that way, and show you got the image. Can select another ones here and still get the right image, and it's being loaded correctly. Now, first step complete, loading the image, and we having it right into like the box in here. So whenever we click select, we pick up an image, it gets right here. Now the second step is the most important part, obviously, to run the object detection of that image. So like as soon as the image is available, as soon as we render up the image, we're going to start detecting or start the process of detecting images, or pretty much detecting objects inside of the currently rendered image. And this is where the TensorFlow and all the models are going to work in, and the neural networks and everything. So this is probably where the all work is going to happen behind the scenes. Now, to use that, we can go ahead and use the actual API of like how to detect an image. So we can create a function in here to detect an image. So we're going to do like detect, we can call it probably so detect objects on image. Okay, we can use it that way. That's a pretty good name. Yeah, here what it needs, we're gonna need to pass in an HTML image element. So we need to pass in an image element in here in order to do the processing. You can either take a canvas, an image element, not sure what else, a video HTML elements, I guess, but we're gonna pass in an HTML image elements. Okay, so we're gonna have this like image element. Now, first things first, you have to initialize and get a model from the COCO's model, or the COCO-SSD. So you have to do COCO-SSD load, and here just pass in an empty object to make sure like you're not going to use any configuration, just to use the basics ones. And we got the model here. The second one you have to do, and this one is await. So we have to use async await because it returns a promise, and we have to wait it to fulfill in order to move to the next. Now, after it fulfills, we have to do like the model dot detect, and this one is going to start the detecting, and we're going to be passing it the image element, right? And here you can pass in like max num boxes and minimum score. We can do like the max num box is going to be 10, and it defaults to 20. Okay, so 10 can like make a little bit more performance. You can have like 6 or something. It will make it a little bit more performant, right? and this will do the full detection of this, and it will return the predictions. So we're going to have like this prediction is actually an array which has all the info we need to render out the bounding boxes around the object that this model has just detected. Okay, so this projection is going to be like an array with a bounding box, or going to be like the x and y, the width and height of that box, and it's going to be like what is the class, which is like what is the type, either a dog, a cat, a person, a microwave, whatever, and a score. And the score is actually just like from 0 to 1. You can just think of it like a percentage of how well this one is predicted. So like 1 is really perfect, and 0 of course is awful. And you're gonna get some like number around like 0.8, 0.9, 0.7, those numbers. It's never gonna be accurate for sure. Nothing is accurate here. Okay, so here we got the projections, everything. Now let's go ahead and make sure we get the right image, right? So when here into like prepare and create an image element. So to do so here, we're going to be doing, I'm going to create an image element. I'm going to use documents.create element. I'm going to create an img, and the image element in here, we have to assign the src into it. And the src is going to be just like the base64 data that we have just loaded. That's pretty much all. Now also inside of the image element, you got like a callback. So it's going to be on load, which means only loads the data and it renders it, but it's not going to render it on the browser. It's just going to render it behind the scenes. So the user won't see that, just like it renders it temporarily, so we can like get access and create this placeholder box container of an image element, so we can later on use it for data processing and image detection. Okay. So here, once it loads, once everything is actually being loaded and everything, what we can do is make sure to run this asynchronous. So we just like wait for things to run, and we can just go ahead and do something we call the detect object on image, right? So call this one. We got image elements, and we have to pass in the currently image elements that we got. So once it loads, you're just gonna pass the image element, and it can start working with it. Now what I can do here is just gonna console log predictions, right? Sweet. So let's go and try out again. Let me just gonna put up the console real quick so everyone could see. And yes, we got an issue already. So I'm gonna select, let's go select this really sweet dog. So here, you're not gonna see it, but it already started like object section, I believe. So it already started the object section, and it's gonna take quite a couple of seconds to do the pretty much the object detection, because it's not really like, you know, there you go, we got it. But here it's not really powerful in the browser. This is actually the downside of running it on the browser, running machine learning or, you know, object detection, whatever, on the browser, because it takes quite time, and it can like freeze the browser if you're not running it on a web worker, and yada yada yada. So issues like that. And this is what we got stumbled in here. So it takes a couple of seconds. Sometimes it just does it really quick, because it depends on the computer, depends on your CPU, depends on the GPU, whatever. So this kind of things. If you got like pretty powerful computer that is only designed to do this object detection, well, you're gonna get it in like probably milliseconds or even less. So yeah, that's the point. So for the predictions in here, that's what we got. We got an array. So this is the first index. We got a single prediction because we only got a dog in this picture, and it has like a bounding box. So it has like a, so this first one is actually going to be X, Y, width, and height. And the class is dog, a score, you know, 0.98. 98 is a really good score. So it's pretty much like 100% accurate. This one is a running dog. And yeah, so we're going to just, depending on this information, depending on the X, the Y, you know, whatever the width and height, I'm going to draw a bounding box. So you see like on these image detections, they draw like a box surrounding the object, and on top of it, you're going to have like the object's name. In this case, is going to be like a dog, and pretty much like next to it, you're going to have like the score or the percentage, like 98%, this is going to be a dog, or 50%, this is going to be a motorcycle, this is going to be a person, yada, yada, yada. So this is exactly what we're going to be trying to render using React right now after the object detection has finished running. Okay, cool. So, right, so what we can do here, let me think about this so for a second. We got like the image data, we got everything that we're gonna be like trying to use. Now I have to hold the predictions in here. So we're gonna have like set predictions, and I'm gonna use the state to set and hold the predictions, right? I'm gonna just like have them on empty array. I'm gonna have like a boolean detects if predictions are empty or not, which means it has already detected it or not, so we can render the boundary boxes. All right, so is empty predictions. So if so, like we're gonna check empty predictions, so not predictions, so if they're null or something, or predictions length equals 0. So either of any of these is going to be like empty, the boolean here, and we're not going to be rendering anything, right? So this one's going to decide what we're going to be rendering. Pretty cool. Now for the bounding boxes, we need to render a custom bounding boxes, and that's what we're going to be creating right here. So I'm going to have like targets, let's say, so targets box, let's name it a target box. It's going to be just a simple div and nothing too complicated actually, just to worry about or something. And this one is going to be having, and this is what I talked about before, it's going to have a position absolute. So just like you can, absolutely position it whenever you want on the image. So you got position relative in here. So it's going to be relatively positioned to the detector container, which holds the whole image. And that's exactly what we wanted right there. So we're going to have like this one, and we're going to need to like grab from the props information we need, like the X, the Y value, and stuff like that. So for the top in here, we're going to have like to grab the X from it, and we're just going to do X plus pixels, right? And this is pretty much going to be the same thing. Let me just put a semicolon. So we're going to have top, so it's going to be Y, and this one is, yeah, I'm totally wrong about this. So this one should be left, this one should be top, so width and a height, alright? Again, width, height there, and height right there. So this one should do the job perfectly. I'm not gonna have like some border onto it, so I'm gonna have 4 pixels solid, probably gonna have some greenish color around to it. I don't know, I feel like a boundary box should be green, but you can put whatever color you would love to. You can even randomize this, but I'm not gonna just like go through it. So background color, I'm gonna have it transparent, so it's just gonna be a boundary box, right? It's an empty box where you got the border. Pretty self-explanatory. Now to display the label that we want, actually to display, for example, the bounding box, then on top of the box, we want to display like what is the type of like that object that has been detected. So for example, a dog, a cat, a person, whatever. To do so, we need to use pseudo classes to be able to render either before or after the current element, which is the target box. So I'm going to use before for that case. And I'm going to have like content to be put, and make sure to use here like double quotes, otherwise it won't work for you. So I'm just going to like include from the props. I'm going to have it like, for example, the class type. So it's going to be like the class type and the score, because we want both of them to be displayed on top. And we can just like have it, let's say it renders something like, I'm not sure about this. So we can have it, for example, we can use string literals in here, and we can combine class type. Okay, I can't type literally. So class type, then plus score. So just like, you can have the score in here, and the score is going to be like a fixed number. So it's going to be a really long number as you've seen in the console. So what you want is actually like 2 numbers after the comma there. So just 2 decimal points. So we're going to have like 2 fixed, and you can pass in 2 here to have like just 2 numbers after the decimal. Pretty cool. So this is the content we wanted. For the color, I'm going to just basically use the same color here, just to make it really obvious. So font weight should have like 500. Font size we can pretty much use like 17 pixels for that case or something. Okay, and position can be absolute. And since I've tried it before, so I know what is the top value, just like to put it on the top, I can put 1.5 AM to make it happen for that case. And the left you can just like have -5 pixels, right? And that should do the job for us perfectly. Now, pretty cool. So we can go ahead and use this one. We can render out depending on the predictions array to get these bounding boxes in the right position. So we can go ahead inside of like detector container, make sure to put it there because we got absolute positioning instead of relative positioning. And this is where the image lives. So you want it above the image. So if anything happens, what you want to do also, what I totally forgot about doing is actually the Z index. You can put something like 20 or something higher than the image's Z index. Otherwise it won't be visible for you. So here I'm gonna just like make sure it is not empty in predictions and predictions.map. So we can have prediction and an index on it. And we can simply just gonna render out a target box, right? Now for the target box, make sure to pass in a key for React purposes. Next we're gonna have like the X, remember, so we're gonna have like inside of like prediction.bb or bbox bounding box, and we need to access the first elements on the array for the X, so 0 there, and Y, so prediction again, B box 1 here with one more prediction dot box 2, and last goal is we're gonna have the height, so it's gonna be prediction dot box 3. Okay, 2, 0, 1, and 3. And we totally forgot about the class type, so make sure to do so. Prediction dot class and the score, right? Okay, and we need the score. Pretty simple. Now we should do and render up all of these depending on the predictions as soon as they are available. Now we need just like to populate the new array with the new predictions as soon as they came out. So we need to do like set predictions real quick, and it's going to be predictions. All of that should be in the right place. Now let's go ahead and test these things. I'm going to refresh just, for making sure that everything is loaded up correctly. So I'm going to use my old doggy image here, which is pretty perfect. So we should like, object section should already started, I believe. Not really sure, but we will see if prediction is going to come out any second. And if we're going to have like, okay, so it should, yeah, there you go. So we got the predictions in the array here. And what we got is actually a surrounding box. We got dog right here and a 099 for pretty much the score. So it works perfectly. But those of you who are saying, oh, that's weird, the box is not centered, is not like positioned around the actual object, which is the dog. Yeah, you are right. And the total reason for this to happen is because, like, remember here, if you're doing the code, it's actually we're giving us the full image, which means the full sized image as we got it from the disk. Like, for example, this image is going to say 500 pixels by 500 pixels. So we're giving it this particular ratio, this particular resolution to the image detector. While here, we are actually, minimizing or cropping this. We are using the height to be 700 pixels. And the width is going to take whatever aspect ratio depending on the height. Pretty weird, right? So we are resizing the image without resizing pretty much the bounding box in here. So the bounding box in here got, so the predictions bounding box in here, what we got, like this X values B box is having the old values from the full resolution. It's not using the resized resolution. So to do so, we need to do some like normalization. If you're not familiar with math, well, won't be probably super hard, but all you need to do is just like translate the old positions into the new ones and we can use like the old width, the new resized image width, and yada yada yada. So we have to access the new image rendered width, which means we need to access like to this particular image, and therefore we have to hold up a reference into it. So we can go ahead and do that real quick up here. So we can do like image ref, use ref, and down here we can just pass in a ref. So image ref, right? Yeah, I guess pretty cool. Now here we can go and have another function. It's going to do the normalization for us, so we can give it the predictions. It does all the math, all the translation necessary, and returns the new predictions with the new bounding boxes. So we can do like normalize predictions. So for this one, we can just like have it passing in the prediction. Is going to return it for us. So here we also need to pass in the image size, I believe. We will see about that. So if not predictions, like if it is not valid, all you need to do is like return an empty array. Otherwise, you're gonna have return predictions.map. And if you're not familiar with array map method, the map method itself, clear in here, it returns an array, which means the prediction is gonna like return an array, like just mapping the predictions into whatever value, and it just returns that particular arrays of predictions. So we're gonna have prediction in here, and we're gonna do all the calculation inside of that particular object. Now we have to be able to access to the image size of that image. That's why we're having like the reference in here to be able to access it on behalf of all of that. So yeah, that's pretty much all you need, I guess, for here. And for this one to work, the normalization, we have to access to the original image resolution, which means width and height, and we have to access to the resized image resolution, width and height too. So to do so, we can go ahead and like here, once we are reading an image, remember we are already reading an image, we're passing it all the data. So this image elements can provide us with width and height. So to do so, we can do like const image size. I can have width of image elements to be its width, and height, image element height. And that's what we need there. So image size, I'm going to be passing it to the detect object, like an image, and we can just like have it here. So image size, and we can pass it down to the normalization. And here we could, where is it? So we can go ahead and accept it to right there. Now also we have to check and the image size is ready. So if not image size, we can just like return empty here, empty array. That should do the job for it. Now for the calculation to work, we have to get like the old X values and we translate them with whatever factor that the image has been resized with, okay? So this is exactly what we need to do for that. So I'm going to destruct in here, I'm going to just like destruct the B box from the prediction itself, and we can have like the old X of B box 0, old Y, B box 1, so old width 2, B box 2, so like the old width of the B box, so we can do the translate with it, and the same for the height too, so B box 3. Cool. Now we got these ones. The image size in here represents the original image size, and the image reference in here, which is the newly rendered image, which is the newly resized image that we want to do all the translation to. And this, like the new width, we have to do like division on, we have to do normalization on. So we can do like img width equals image ref dot current dot width. And one more thing in here, we have to do check in, make sure that the image width is valid. Otherwise, we're just gonna like return. And we don't want to return an empty array, so we want to return either predictions or empty array. So it depends. If this one is null, which means null undefined, it's going to return an empty array. Otherwise, it's going to return predictions there, if that makes sense. So next one, we're going to have image height, so image ref current the height. Pretty easy, cool stuff there. And yeah, so this was just like doing, like grabbing the values to make them a little bit more easier to understand. Now, the most important part is actually doing the translation. So if you're not familiar with like the third multiplication division rule, well, like, you know, it's more like, I don't know how to say that mathematically. I'm not really like a mathematic person, but you should already be familiar with that if you like had a decent mathematic course, or algebra course. You would probably know that. It's just like super logical. So we're gonna have const x, which is the new x of the bounding box that we need to translate to. So we're gonna use the old x here. We're gonna just like do time the image width, which is the newly added image width, and we're gonna divide it with the image size dot width, which is like the original width. So we like do old x, the current width, times, then we divided whatever width like was originally the image width, so we can normalize it back again. Okay, so this one is actually just mapping it to the new width, then like normalizing it with the old width so it gets the right position again. So we're gonna do the same thing in here for the y. So I'm gonna do const y, old y times image height, because y is, you know, a vertical axis, and we got the width, so old width times, where is that? So image width divided by img size dot width, and last but not least we got the height, so we can have like old height, okay, image height divided by image size dot height. Pretty cool. Now, after we do all the translation and everything, the x, y, the width, and height, all we need to do is just go ahead and return an object so the map can do its job. So every single item is going to be mapped into this new resolution, or pretty much this new positions and, you know, bounding boxes, width and heights or sizes. So we can just like do here, use whatever the prediction has before. Then we can just do the b box and add into it the new value. So x first, y second, width third, and height the fourth position. Pretty cool. So this one's going to return the new prediction. It's going to do all the normalization for us, and it's going to have it right into the point. Now, before setting predictions in here, what we want is actually do like normalized predictions, and we can just like do normalized predictions. This one passing it the predictions and passing it the image size. Okay, now we can just go ahead and have it, I don't know why I'm passing set predictions image size. Pretty weird, right? So normalized with an ed, and I believe that would make it work perfectly with the bounding box into the right position and just translating it, the x position, y position, width, and height into the right position. So let's jump right into here. We're gonna refresh everything again, select a new image, let's select the new dog. Well, here currently we don't have any indication that's pretty much this is being processed, so we can add some like text in here. Whenever you just like stop processing, we can do like recognizing or loading or whatever. I'll do that in a second after checking that this one is working. And as clear as it's taking it quite some time, but voila, so we got already the image detection work, and the bounding box is actually right into the position of the dog. So we got dog 0.99, you can even have it in percent in here, and you got the full dog in here is being like recognized and how it works. Booyah, so you got a full object detection working the right way as you want it to be in here in a really perfect spot. We can go ahead and just like work with this score real quick to make it more like a percentage. So we can, all we need to do is just like the score times 100, and yeah, we got two facts there, right? I think, where are we when doing that? Yeah, on the top. So we can do just percentage here. Okay, where is the percent? Sign. That should be outside, right? Cool. I think that would make it work 98.88%. Yeah, that sounds bit better, I think. I don't know. Try to do one. Yeah, I think that's better. So 98.9%, better than 0.99. You got the points. But yeah, we got the docking here as being like, putting into perspective, the boundary box is exactly putting inside of the dock, even though we got a resized image. So we're doing a full normalization. It's working perfectly fine as we want it to be, to like surround the full object that we want to detect, right? So we can go ahead and test it out with a couple of more. Let me just go ahead and close this one. I want to have a little bit more performance. Maybe we can get rid of the like WebGL as we read out there, just to make it a bit more performance. Maybe yes, maybe no. But let's try this one. It's quite pixelated. I don't want to just like use super huge resolution, you know, because it takes a lot of time to process depending on the resolution. So we got it fine here. I already got some matching. It's not matching all the cars where it should be, but it's matching like 3-4 of them. So 80 here, 64, 84, 69 for some reason. So yeah, for detecting all of these, you need like more power, more trained model, and probably like a lot of processing, a lot of time processing this. So here, security, that's an issue. It's still stuck with the old images already, so still stuck in there. Security now, that's another issue, right? So it has like gone into, like, has changed and updated this, but only after the recognition has completed. So it hasn't cleared out the already recognition after just selecting a new image. So what I want to do, so set predictions. I want to just like clear out the prediction and making it like an empty array. And the next one, I want to put a loading just to make sure that things, oh, we know that is putting loading, right? So I want to do is loading, set loading. I can have use state, so false. And down here, so whenever he starts selecting an image, we can do set loading to be true, right? So I can have it true, and whenever he finishes, only after the await, which means it has been finished successfully, we can just set loading to false, and that should do it. And here we need to use that new variable, so let me just put this between quotes. So right now I need to detect, so if it is loading, right, I'm going to do like recognizing or something. Otherwise, just display select image. That should make it perfectly right now. So refreshing again, selecting cats or whatever. Screws here we got recognizing, which is pretty great for user experience. So now we know like, oh, this being doing some magic there. And voila, so we got like cats, 84%, 83%, 86%. It's not detecting all the cats as it might seem to be. For some reason, this one won't be detected for a cat or something. Pretty weird stuff, but yeah, we got some of it working pretty fine. Here we got another 2 cats. They are like completely, I don't know, merged into a cat. I believe I've tested this before, and yeah, it just says this is a complete cat, while it's not, obviously, and it's having like 80%. So sometimes it like throws into you weird stuff. So yeah, you're never gonna get it right, because that's machine learning, and you're not having the best data set, the best model here. It's not fully trained, and though it is running the browser, so you're not gonna like fully reliable. If you want it to be fully reliable, you have to test it on your own. You need to like a lot of processing power, a huge CPU, probably a GPU because of WebGL. You're gonna need a lot of like, you're not gonna be using it in the browser. You need it somewhere else, but for the browser in here, it's still like lacking a lot of performance accuracy. It takes quite some time to do it perfectly, and yeah, it's all being done in the browser. It's not sending an API or something. So all the computation is happening locally in the browser. As clear as what it happens, like saying this is a motorcycle, car, a bus. This is another car, and yeah, so it's getting it right. The bus is right. 2 cars, not detecting the other cars for some reason. All the motorcycles is not, only this one. Okay, pretty weird stuff, but yeah, so another cat image in here. This one is really high resolution, and it might take some time, a couple of seconds to do though. And pretty much you see here, it got it. The cat is 96% to just like do all the shuffling in there. But what I have actually seen throughout the documentation, so if you want to make this a little bit faster, what you need to go through is actually you can remove the post-process graph from the original model, and this should make it like 50% quicker than this one and much more performant than this one. So you can do this one, and you can like generate your own custom model. Then you can point into this custom URL model with the COCO-SSD initialization of the model, and you will get it right. But I haven't done that in here. If some of you guys like got the chance to try this one, because the video will be too long and it doesn't really worth it. So we got the point in here. We actually showed exactly what you can do with React.js, TensorFlow, COCO-SSD, and object detection and browser real time. And it's not really real time, but yeah, it's objects and it detecting images really good. And it's all been like put on the browser with normal HTML, CSS, and JavaScript, and a little bit of React here and there, and it's working absolutely fine. So yeah, I hope you guys enjoyed this video, as I enjoyed like making every bit of it. Probably like you liking it more than I do or not. I'm not really sure about like this type of videos, but the last one I've released about voice assistant and using this machine learning, you liked it a lot of you, because it was just like a really awesome idea, and just like getting these ideas from here and there. So if you're really liking this type of things, if you like liking machine learning on the browser with JavaScript or even on Node.js, let me know. I will try to do more, because I do really enjoy to do this kind of things and get into the AI world with you guys. So nonetheless, guys, hope you guys enjoyed it as before I said, and hope you guys enjoyed it as always. So thank you guys for watching. Catch you all hopefully in the next ones.